Okay, I'm going to try and do this one super fast to recreate the stress of a test, which, oh my god, I have a test tomorrow. Okay, so let's do this. First thing, I want to look at nitric acid. And I know from looking at the interweb, which never lies, that the density of nitric acid is 1.51 grams per centimeter cubed, and I know that the molecular weight of it is 63.01 grams per mole, right? Okay, and I want to find the molarity, the molality, and the mole fraction of nitric acid in a solution whose mass, let me rephrase that, in a solution where nitric acid accounts for 85% of the mass. Well, let's start with the first one first, molarity. Molarity, we want to start with the end in sight first, right? We want to say what's the number of moles per liter, right? All right, yes, of course I'm right. So I know that if it's 85%, that's going to be for every 85 grams of nitric acid, I'm going to have 1 liter, I should have done this first, of solution. Well, that's totally wrong. Okay. We need to come from the mass percent. So if it's the mass percent, I know that out of every 85 grams, I'm going to say 100 grams of that is solution. Okay, out of every 85 grams in 100 grams of solution, that's what the mass percent means. All right, now with grams on top and grams in the bottom, really I want to say how many moles per liter. Well, first of all, I need to know the molecular mass of nitric acid, which conveniently I have here. So I'm going to say 1 mole. Let's make that a different color. Yeah, colors. We like lots of colors. Okay, 1 mole of nitric acid. Is that what I want to get rid of? Yeah, I do. HNO3. The lag is killing me, man. Okay, let's do it without that. 1 mole of it's getting late. I've been studying all day. I'm going crazy. Okay, is equal to 63.01. That's a 6.01 grams of the same stuff, and that gets rid of grams here and grams here, and really I should have put that here so we could cancel these out. You can pretend I did it, and then that gets us so far good. That's right, that gives us moles, so we can say check. Now I want to put liters down in the bottom. Well, I know that oh, I forgot something. We need the density, or else we're not going to get very far. So I should have put this in the first step, but it doesn't really matter. For every 1.51 grams of solution, there are going to be, or there will be 1 centimeter cubed. So what I want to do now, by the way, these grams cancel out, is I want to get this into liters right here. So let's move over a little bit. Okay, so liters, liters, liters. Oh yes, how many cubic centimeters in a liter? There are 1,000 centimeters cubed in 1 liter. Okay, and it doesn't matter what at this point. Okay, so now let's start crashing through here. Oh, this cancels with that, by the way, and the moles need to stay there. That's good. We've got our liters. Let's do some arithmetic. Okay, Shazam, there's my calculator. Wow, that was great. I was a little slow on the response, I realize. Okay, so now I'm going to say I have 85. A lot of wires around here. 5, like a good nerd. Okay, obviously we knew that was going to be the answer, but 63.01, I'm going to divide that. So 63.01 divide, oh, whoops, I wasn't watching myself there. Okay, and 1.51 times, and 1,000 times, which, here, maybe you can see that better. 1E3, that's 1,000, right? times, can't see my times button with the screencasting software. All right, and that comes out to 20 what? Well, it comes out to 20 molar. 20. It's a 20 molar solution of nitric acid at 85%. Okay, good. We're there. Next step. Okay, what I want to do now is find the molality of the same solution. Well, molality is a measure of moles per kilogram, right? All right, now we can come from the mass percent again, and we know that 85% of this is nitric acid. So we could say that, let's put a line here, 85, for every 85 grams of nitric acid, that's a 5. There will be, well, 5 makes that 90, 15 grams of water, because this is, I'm saying this is an aqueous solution. Okay. Now with that, what I can do is I'm going to say I want moles and I want kilograms. Okay, so for that I'm going to say 85 grams. Well, I want 1 mole. We just did this up here, right? Of HNO3 over 63.01. Okay, grams of the same stuff. Okay, and I'm going to multiply that. Now I've got moles, right? Good. All right. Well, now I've got grams down here. This gram thing here, that gets to go away though. So grams of this, grams of that, and technically this goes too. All right. Now I've got grams down here. I want kilograms down here. Well, there are 1,000 kilograms. Excuse me, 1,000 grams per 1 kilogram. Hey, that was easy. And now I'm done. I just need to do the math. So I'm going to take a look at this. I'm going to say 85 divided by 15 divided by 63.01. Why does it do that? Why do I do that? Okay, 0.01. Oh, good grief. Okay, I'm trying to type with the stylus here, and it's a little tricky. Divide, everybody has to have an excuse, 1E3, that's 1,000 times. That means this is about a 90 molar, or not molar, molal. And looking at sig figs, that's as close as we can go. So 90 m lowercase m, and that's moles per kilogram. That's moles of solute, kilogram of solvent. I'm not going to write that out. Okay, next, because I said this is going to be fast and I totally lied. The last one is the mole fraction. Good grief, that's ugly. Okay, the mole fraction. Greek letter chi or chai or latte or something like that. I'm going to say, because I'm looking for the solute, I usually just put A, and that helps me remember. B will be my solvent normally. So the mole fraction, well, the moles of A is going to be 85 grams. Divided by 63.01. We're working from percentages here now, and so that means I have 85. I have so much more I want to do tonight. 63.01. Oh crap! I'm gonna start using the 10 key. 01. 85 divide. Okay, so I have 1.35 moles. Okay, and now I need a value for B, which I said there's 15 grams of water. So say N. No, that should be blue because it's water. Okay, NB. is going to be equal to 15 grams of water, and that's 18.02 grams of, yeah, you know what I'm doing. All right, so I say 15 grams divided by 18, and that gives me 0.83 moles. Okay, now I'm going to say, oh, did I not write that down? Brilliant. Oh, yes, I did. Okay, here we go. So I've got this, I'm ready to go. 1.35 moles of nitric acid over 1.35 moles plus, this is going to be the total moles of the solution, 0.83 moles total. So I conveniently have that right here, 1.35 plus, and I'm going to say 1.35 again, and fancy HP calculator trick, I'm going to swap places with those. This divided by this, that is the mole fraction of the nitric acid for NO3, HNO3, otherwise it wouldn't be nitric acid, it'd just be a nitrate, equals 0.62. And if you wanted the mole fraction, I said, of B, then that would just be 1 minus mole fraction of A. And that's that. 11 minutes. I guess it could be worse. Talk to you later.